connected graph.
Okay, so BFS is one of the topics which comes under the graph theory, and it is an important part of our MFCA syllabus. So BFS stands for breadth first search. So what will happen is that a graph will be given to you, and you have to write the sequence of the breadth first traversal. So let us consider a graph. Let us make it a simple one. Just I'm naming the vertices. Okay, let's say it is A. So this graph has been given to you, and the question is being asked from you. Suppose you start your breadth first traversal from the vertex A. Let's say from vertex A. Then what will be your sequence to traverse this graph? What order will you follow? So how to know that sequence? The procedure I'm telling. So firstly, you have to maintain two arrays. Okay, or I should say data structure. You let's say now we have been the source has been given to us. It's A. Okay. So firstly, the source is A. So just put A in the queue. Okay. So I'm using this variable. It is a queue data structure. So the property of a queue data structure is what? We add the element from the behind, but when it comes to take out the element, it is taken out from the front. Okay. This is the property of queue. So we shall be maintaining a queue data structure, and so our source is A. Okay. So just add it in. So our queue becomes A. This was our first step. The second step, what we will do is, we will do a pop operation on queue. What does a pop operation mean? Pop operation means picking out the first element of the queue from the left hand side. So pop q.pop, in the sense of computer science, we will do q.pop. What we will get? We will get A. Now put this value in the visited array. A has been put inside it. Now look at the neighbors of A. Who all are the neighbors of A? B, F and E. The immediate vertices which are connected to the source, we call it the neighbors. So B, F and E are the neighbors. So since we have popped out the element of A, Q here is empty. A has came out. Okay, and we have put A in the visited. Now, what all are the neighbors? B, F and E. Okay. So whatever neighbor we just found, put it in the queue. P, F and E. B, F and E. Okay. Now, this can be in any order. So for example, we can put like B, F, B and E also. It doesn't matter. The order doesn't matter how you put. Okay, so let's say we put B, F and E. Now, again do the pop operation. Again q.pop. What will happen? Q.pop will return B this time. Okay. Now, look at the neighbors of B. Who all are the neighbors of B? C and A. C and A are the neighbors of B. But A has already been visited. Okay. So what we will do? We will add only C in the queue from behind. So after the pop operation, our queue was looking like F and E only, because B has already came out. Now the neighbors of B are A and C, but A is already visited. So we will add C only here. Okay. We have added C. Now again do the pop operation on this queue. Q.pop again. What we shall get? F. now F has been removed from here. What all are the neighbors of F? C and A.
Yeah.
F has neighbors C and A. But in the visited, I'm sorry, I must have added,
C.
no.
C, I think.
B.
B.
Yeah, B. I must have added B and
Pop B.
yeah. So F has been popped out and the neighbors of F are A and C. Okay. Now A has already been visited. So we will and
At
C has already been visited. Okay. So now in our queue, what we will do? We will neighbors of F are C and A. And C has not been okay. So we will not add C because it is already there. Okay. So E and C are already there, and now F has been visited.
Now, how will we know that C is already in the queue? Because in visited there is no C.
No. But it is in the queue. It is C is not here, so you will see add C here. But C, since C is already here, you won't add.
Okay.
Okay. Now, okay. So the neighbors of F were A and C.
C.
Okay. So E and C are the remaining ones. Now again do the pop operation. E will come out, and our Q will become C only. Okay. Now check the neighbors of E. E has neighbors D and A. Okay. So since A is already there, so I'm sorry, we have taken out E, so E will be there in the visited. And the neighbors of E are A and D. Here we have only C. We will add the neighbor D from behind. We will not add A because A is already visited. A is already visited. So we will not add A again. Now again pop the element C from here. C will come out and we will have D. Q will be D. Now neighbors of C are B, F and D.
Try to write last line clearly. Last line.
This one?
Yes. Raise and clear.
Okay, so what we did just was, we had C and D remaining in the queue.
Yeah.
We just did the pop operation. So C has come out. Now our queue is, we have C out and Q has now become only D. Now we are checking the neighbors of C. Neighbors of C are B and D.
Yeah.
Both, okay, so
Now D is visited.
yeah, B is visited and D is not visited. Okay. So
C is visited, I think.
yeah, C is visited, so I will add C over here. And the neighbors of C are B and D, but B is visited, D is not visited. We need to add D in here, but D is already here, so we will not add D also. So we have the remaining element D, we will add it, write it as it is. So the first traversal of this graph will be A, B, F, E, C and D. This will be the sequence of BFS for this graph. That's it.
What we have to search here? We have to only find the trend.
Yeah.
And the